All right, we got solving two-step equations. Why is it important to perform the same operation on both sides of the equation when solving? All right, so let's get started. Let's recall the order of operations. We know this. PEMDAS. Please excuse my dear Aunt Sally. Now, I know a lot of teachers like to teach it this way, right? Nice, beautiful words and stuff, but I like to write M and D next to each other because it really depends on who comes first. And addition, subtraction, same thing, who comes first. So you don't always do multiplication before division. It depends on what comes first when you go left to right. Okay, so anyway, just a refresher. So if I'm looking at this problem here, this is 2 times 5 plus 3. The first thing you do is before you add, you multiply. You do something like this. 2, then you times it by 5, and then you add 3 to it. You get 13 as an answer. Well, guess what? When we solve equations, when we're trying to solve and find out, hey, what was, if I said, hey, something times 5 plus 3 gives me 13, what was that something? I just work backwards, okay? So to find where it started, go in reverse order. So start with 13, and you say, all right, instead of plus, let me erase that part and go backwards. So that means instead of plus, I would subtract 3, okay? So you're actually going to do PEMDAS the opposite way. Take care of addition and subtraction first, undo that part first, then take care of any multiplication and division. So anyway, 13, instead of plus 3, I subtract 3. Then we move over here. Instead of times by 5, I divide by 5, and then I'll end up with my answer. See, 13 minus 3 is 10. 10 divided by 5 is 2. That's where it all started from. Okay, so in basic two-step equations, here's the real key here. Just remember, okay, for the most part, this is what you're going to see for the most part now until probably throughout high school too. Undo addition and subtraction first. That's the bottom of PEMDAS. Any addition and subtraction, get rid of that first. Undo, right? Inverse. Then you undo any multiplication or division. Okay, so those are the two main steps that you'll be dealing with, two-step equations. All right, so let's solve and check. Here we go. Whoops, I gave you too much. It's all right. 2x plus 3 equals 9. All right, so I want to go, I already know the answer. I want to know where it started from. So the first thing I notice is I'm going, hey, x times 2, and then add 3 to get 9. And I remember to myself, hey, PEMDAS, but backwards. Take care of any addition and subtraction first. So I see addition here. I will subtract 3 on both sides. Undo addition by subtracting 3. Subtract 3 on both sides. I get this, right? So by subtracting 3, that cancels out. This just drops down, and these two simplify to 6. So then I want to undo any multiplication. In this case, I'm going to divide. Divide by 2. That's undoing multiplication. That's this step of PEMDAS. And I end up with 3 as my final answer. Lastly, I just check my work. I go back and say, hey, if 3 is what I think x is, let me go see if it works. 2 times 3, well, that's 6. 6 plus 3 is 9. Yes, it does work out. All right, let's try another one. Here we go. What do we do first? Well, 3 times x plus 2 equals 23. If I go backwards here, get rid of any addition or subtraction first. Undo the addition by subtracting 2. Okay, so let's see what that looks like. By subtracting 2 on both sides, this crosses out. This drops down because that was left alone, so that just drops down. And these two combine to give you 21. If I then undo the multiplication by dividing by 3, okay, divide both sides by 3, I get 7 as an answer. Okay, 7 as an answer, good. I got my answer, I just need to check my work. Go back and plug it in. 3 times 7 is 21, plus 2 should give me 23, and it does. All right, here we go. Let's go on to 2 more examples. All right, here I go. Negative 2 times y minus 7 equals 3. Remember, take care of any addition or subtraction first. Over here, this is not subtraction. This is negative 2 times y. So we'll wait to that one. But here, this is subtraction. So I'm going to undo subtraction by adding 7. I add 7 to both sides. That eliminates this. This just drops down. And 3 plus 7 is 10. Okay, then I'm going to undo multiplication by dividing. This time I divide by the coefficient, which is negative 2, on both sides, and I find out my answer is negative 5. Okay, so I'm going to plug it back into the original equation. Negative 2 times 5, negative 5, minus 7, does that equal 3? Well, let's find out. Does 10 minus 7 equal 3? It does. All right, and then for my last example, here we go. All right, we got some fractions, some rational coefficients. All right, 4 plus 1/5 times x equals negative 1. This is multiplying. I'll take care of that in a second. Here's what I want to get rid of. So the opposite of a positive 4 is to subtract 4. I subtract 4 on both sides. That crosses that out. That drops down. And that gives me negative 5. Next, if you remember, to get rid of a fraction, we just multiply by its reciprocal. So to undo multiplication, you divide by a fifth, which is the same as multiplying by 5/1. Multiply by 5/1, these cross out, I'm left with x is equal to negative 25. And you guessed it, the last thing I do is I check my work. Negative 25, plug it in right here, just like here. 4 plus 1/5 of negative 25, is that negative 1? Well, I find out that 1/5 of negative 25 is negative 5, and 4 minus 5 is negative 1. And that works. Okay, that's it for notes today.